Welcome back to another working session. And I did some off-camera work about creating a wall, a new kind of construct. So let's review that. First, I started with the schema, since that worked well for a box. So a wall is a mutation, create a wall, space ID, and you can give the wall an optional height, otherwise we'll default it to maybe 2 meters tall. You can provide a list of points, and these are just points on the ground, so typically in X and Z, which is just a list of pairs. And then we'll go to the create wall resolver. This will pluck out all the arguments, and then everything except space ID we map into a list, and then we pass that along to the create entity. That will just get saved into the database and broadcast. And then on the scene manager side, for everything that is an entity, we kind of pass it through this finder create mesh. And if it's the wall, we will look up the components we care about, which is height and points. And this might be missing actually. So this could be totally missing. So maybe we should always create height. Or if it's missing, let's see, entity components filter. So this could be null. So can we do a safe operator, which I think is this? If this is null, let me just test this out. So give me Chrome. TypeScript playground. Okay, so if I have an array and I want to see console log what is a 0. Yeah, A of A. And run. It is undefined. And what if I want to say thing access the thing? It should say failed, cannot read properties of undefined thing. But if I use safe navigation, maybe it's dot and or question mark. Okay, still undefined. And if this had another accessor, it would just still be undefined. So you do something like that. And if there is a data, it always is, but we'll just do that. Or if it's nothing, then give back 2 meters. And let me check the space resolver here. Yeah, it doesn't need it, and we'll be fine without it. And this was put into a constructs file. So going back, you'll pass this into this function, create wall, which we've imported from a constructs file. And what this code does is it takes the name of the entity, height and points, and it will stick all the parts into an array of meshes. So this is an array of Babylon abstract mesh. We'll just stick those in here. So for the points, we'll go through them as a stream of data, pipe them pairwise. So if we get an uneven amount of points, we'll just consider the even set. Then we'll scan through them, counting up the number of or assigning numbers to each pair. So the first one will be 1. So here's our initial value of the accumulator. Pair is 0 and points is nothing. And as each pairwise comes through, the current value will be points, and we're incrementing this. Are we sticking them in points? No, we're just looking at each set of points independently. So this doesn't even need to be an array. It could be anything. It could be undefined. Don't matter. Then you're subscribing to this data. Oh, okay. We are putting parts in here. Okay. Maybe parts should be in here. Let me refactor this. So this is the pair count, and this is the pair. And this is going to just be undefined. Don't really care. This is the pair. This is the pair count. For each pair of points, draw a wall. But if you get an X and a Z, this is only 1 point. This is not 2 points. So you actually need 4. You need X, X, Z, X, Z. You need to, let's see, what is the implementation for pairwise? So you get XY, XY, but you need actually 2. Maybe if you just did another pairwise. Pairwise, that gives you an array of, gives you X and Z. And then if you throw this into pairwise, you'll get an array of X1, Z1, then X2, Z2. and then that should give us what we want. So then this gives you the count. Let's just call it part count. This will be the part count. And it shall be part count part 0, and then this will be a set of points, point 1 and point 2. So this comes back to points, and this comes back to points, which can be empty. Part count. Okay, this will just be an empty thing here. Now, point 0 becomes point 1. This will be point 2. For each pair of points, draw a wall. So we calculate the distance between point 1 and point 2, and we create a wall, which is a box, the name of which we don't really care. The width will be here, the depth will be this length, and the height will be the height of the wall. Added to the scene. The wall will check for collisions true. We don't need to do this yet. We can do this all the way at the end. And then we'll push this into parts. So push that wall there. Then if the data part count is the first one, we want to add just a little bit of cylinder to give it a rounded cap. I don't know if we need this. Let's go ahead now. Okay, so if this is true, you create a bookend here. It's a cylinder, height, diameter, scene, position, copy from points. It'll be the, point 1 x, which we have no x. It'll be point 1 0. And point 1 1. And it'll be the, why is it height divided by 2? Oh, this is the, for the position. Still, why is it? Oh, because it's, we're going to lift it all up, right? And so this lifts it up, and we haven't. So data length. Did we lift this up? We didn't lift this up yet. Then we always make a bookend on the other side. So same deal here, except it'll be point. But what is a point? A point is an array. Oh no. Sorry, we made this a vector 3. Sorry, go back the way it was. But that is correct. Then we find a midpoint between the points. Oh, this is for us to rotate. There's the midpoint, and wall position, you move it to the midpoint, and then you rotate it, and then you merge the message from all the parts. Okay, so this can be mesh. Merge. merge mesh, and then merged mesh dot, what is this? Name equal name. And what else? A merged mesh collidable collision. Never mind the collision. Let's test this out. We'll go to localhost. In our space right now, we have no wall, and I would like to put a wall maybe around this. So I'll grab this, and I'll go to graphical, and I'll add a mutation, create a wall for the space ID whose height shall be 3 and points shall be, okay, x maybe at 3 and z of 0, then x maybe at 3 and z of 5, then x at -3 and z at 5, then x at -3 and z at 0. So if we add this, we created a wall, it's persisted. We should have sent a message to the front end, and let's see, we do have a wall. We do have a wall. Okay, it didn't really have the depth that I was assuming. Now that isn't what I was expecting. Maybe I have the coordinates wrong. Let's see. We're going to start off 3 and 0, then it goes 3 and 0, then 3 and 5. Okay, it should go in. Then from here, -3 and 5, and then -3 and 0. So in my mind, it should have gone like this. Why don't we try a simpler one? Let's just make a corner. Let's go here and just delete it. So menu, tools, delete. Let's go from 3 and 0 to 3 and 5. Unknown component, 3 and 0, height and points, okay. 3 and 0 and 3 and 5. It doesn't seem to be on those marks. 3 and 0. How about 0, 0 and 2, 2? 0, 0, and then, or 3, 3, right? Go to the corner. Bam. What? Okay, we're definitely not doing the pairwise thing right. Let me see. Okay, so scanning of this, let me see what the data I'm getting. So console log wall data, JSON stringify data. Part 1 is 0, 0 and 0, 3. Part 2 is 0, 3. Yeah. Yeah, you're going to draw a point from here to here. You're going to draw a point from here to here. That seems reasonable. 0, 0 to 0, 3 is the first wall. And then 0, 3 to 3, 3 is becomes the second wall. Okay, I don't think you... This first wall actually looks right. 0, 0, 0, 3. Wait. 0, 0. No, this is not right. This first pairwise thing is not right. Pairwise here is taking this pair, and we don't want that. Yeah, you're coming out with more combinations. We want this one, and then this one. Okay, so our XJS 2 at a time. RSJS chunk stream into 2 partition. This is what I want. Collect until you get 2. So I want buffer 3 is buffer count this. So I want buffer count 2. Now what do we get? Yeah. clear this, refresh. Wall data 1.00 and 33. So you get one wall, goes from 0, 0 to, should go diagonally to 3 and 3. And okay, this is correct. This is the data that I want. It's not drawing it the way I thought it would. Let's see, why not? Okay, so you have the first point, which is point 1, and the second point, which is point 2. It should be correct. And so if we just create this box of the right length, but we didn't actually tilt it correctly, right? This creates the wall, and we pushed it into the wall, but we need to, if we just, never mind about this part yet. Find a midpoint, and then we need to rotate. How about if you don't make the wall yet, and then you just make the endpoints? Are these at the right places? And then don't do anything about this, and don't do any merging yet. Or go ahead and merge it. Yeah, that's fine. Merge. You're pushing those things and merge. You should just see two poles. Okay, that is actually correct. No. Wait. 0, 0 is definitely the center. 0 and 3. This isn't right. It should be at 3, 3. Are we at 3, 3? Point 2, 3, and 3. On the graph, it should be around here, right? 3 to the right, 3 deep. Why is it here? Something with no name. It could be part of wall. Okay, it's got wall. Okay, and don't combine them yet. Parts. We need to return something, so just return C1, for example. Oh, whoops. That won't return null. Yes. What is the position of this? Position. Precisely, it didn't get a Z. So how can this be Z? And how about this one? This one is 0, 0, that's correct. And the data you sent for the wall data console.log .1 is .1 as array. Console.log .2 is .2 as array. X, Y, Z. Oh, you can't do from array like that. No, you have to do. That's a problem. X is always the first one, so points 0 and the 0 component, and then this will just be 0 and points 0 the second component. Points 1, points 1. But then we just do copy from float. There really was no point in doing that, right? Point 1. Because we weren't even going to use it. So why not just say point 1 about let point 1 point 2 equal to points 0 and 1. Both points 0, points 1, like so. That'd be like that. sorry, data dot points, data dot, and this is a array of any. Now point 1 x will be 0 and z will be the second point. Same thing here. And now will you put it in the right place? Yeah, that's right. There you go. So now you can also draw the box. And we'll push this in there. And then we'll find the midpoint. Oh, that's why we want to remove this Babylon, because you can do this diff thing, just subtract one to the other. Yeah, that is useful. Put it back. Put it back. That's not good. First point, 0, 0, first point, second point, console. Okay, don't draw the wall yet. We'll have another points. C1 is x and z, x and z. Let's just see about that. Okay. What happened to the data? Point 1 as array, point 2 as array. There's it. Oh. Still wrong. Still wrong. Yeah, x, y, and z. Y is 0. Point 2. What happened here? What happened? Oh, data. Data points. Now it'll work. Como is. And then bring the wall back. It won't, we haven't rotated it, so the wall won't be right, but I think it's the right length. And then allow it to do some math to find the midpoint. And it will be in the middle, and then allow it to rotate. X the points. Fantastic. Finally, we allow it to merge. Okay, now we can delete this. Close this, go back here, and oh no. Let's go, okay, so you go 0, 0. Let's start on the right, so 3 and 0. And stay on the right, 3, go 3 back, maybe 5 back. Then stay in the back, so you go to the left, so -3 and 5, and then come back to the front, so it becomes -3 and 0. So if we create this, boom, yes, that is what I was expecting. Okay, so now we've brought in the logic for creating a wall. And of course we can still color this wall, right? That works. It still works. Cool. And it's on the ground at the right coordinates. Alright, save it.